chemical change. So while I am discussing about that physical change as well as chemical change means today our topic is chemical reactions and equations. Okay. So you know the differences between the physical change and the chemical change. Here main topic is chemical change. So the chemical change it is occurred during the reaction between the chemicals. Here in our daily life we are using that many chemicals. For example, you know that the common salt which is made up of by the sodium and the chlorine. How it is formed? It is also by the chemical reaction. Okay. So it is not an element. It is made up of by the combining of the two elements. One is sodium and also chlorine. So due to the chemical changes or due to the chemical reaction, it forms into the sodium chloride. Okay. So this sodium chloride it is manufactured naturally as well as we can also prepare in the laboratory. Okay. So here let us discuss that what is meant by chemical reaction. Here you know that there are 118 elements are present in the nature. So out of these 118 elements, 90 elements are they are naturally occurring elements and remaining are they are prepared in the laboratory or by the laboratory. So out of these elements we can also participate in the chemical reaction. Here the chemical reaction it is nothing but the breakdown of the chemical bond and it forms into a new chemical bond with the new substances are called as a chemical reaction. Right on. Chemical reaction. Note on the definition. The breakdown of chemical bonds and form into a new chemical bonds are called as a chemical reaction. Here for the formation of the chemical reaction we need a reactants and the products. So these are the two participants we can see in the chemical reactions. Reactants means that any elements which take part in the chemical reaction we call as a reactants. And the products means the newly formed substances which are obtained from the chemical reactions are called as a products. Here the reactants and the products the products are obtained from the reactants. Okay. So let us discuss that the equation. Here during the for example magnesium Magnesium ribbon is burned in the presence of the oxygen which gives rise to the magnesium oxide. Magnesium oxide. It is a chemical reaction which can be represented by the words magnesium reacts with the oxygen which gives rise to the here the LHS are called as reactants and the RHS are called as products. What we call products. Okay. So this can be represented in the word and we can also represent it by the symbols. You know that the symbols of the symbol of the magnesium is Mg, capital M and small g, and you know that the oxygen, the symbol of oxygen is O, which can be represented by O2 because that oxygen is diatomic molecule. It has a diatomic molecule, hence we can represent it by the O2. So the products which are obtained from the magnesium heated in the presence of the oxygen, which gives a magnesium oxide. So it is called word equation, and this one is called as a symbolic representing equation. So we call as a chemical equation. Here the definition of the chemical equation is the symbolic representation of the reactants and products are called as a chemical equation. Once again I will repeat that. The symbolic representation of the reactants and the products are called as a chemical equation. Okay, so we can also represent the states of matter. You know that the magnesium which is solid in state, and the oxygen which is in the gaseous state, and the product which is obtained in the also solid but it is in a powder. When we burn that magnesium in the presence of oxygen, which forms into a magnesium oxide, which is powder, white powder substances we can be formed. So this is the chemical equation. So during that chemical equation, it may cause us the three types of shall I rub this? During that chemical equation or reaction, it forms into it causes some changes, like it changes the states of matter or state, and changes the temperature, changes the color, and also evolves the gas, and sometimes it forms precipitation. So these are the some causes of the chemical reaction. Here changes of the state means, you know that some substances during that reaction it may changes from solid state to liquid state or liquid state to gaseous state. It also causes by during the chemical reaction, as well as the changes of the temperature. Either it may be decreases or increases during the chemical reaction. So it is also one of the changes. Okay, and also sometimes it may changes the color. Sometimes when we are combining the two elements, it may cause us that a white color or any other colors. Okay, and also evolves the gas. Sometimes when we burn like hydrochloric acid and H2SO4, when they react with that metals, it may release us the hydrogen gas, as well as the oxides, which may release us the oxygen gas. So like that we can see that the evolution of the gases, either it may be hydrogen or oxygen or chlorine, any others, it is also one of the part of the chemical reaction, as well as it also forms the precipitation. Here the precipitation means it is not completely or liquid or not, it is a solid substances, just like paint. You know that the paint which is it is not completely liquid state or it is not in a solid state. So such type of substances are called as a precipitation. Okay, so these are the some causes of the chemical reaction. Okay, so let us discuss that the chemical equations. One second. So before that, so we discussed about that chemical equation. In that, first we discussed about that word equation. Is it? So afterwards it forms into a skeleton. So the differences between the word equation and skeletal equation. Word equation, it is completely represented by the words. For example, you know that, so magnesium and oxygen, which gives us to magnesium oxide. Is it? So here that magnesium can be represented by the symbol in a skeletal equation, and oxygen can be represented by O2 in the skeletal equation. But in the word equation, we represented by the magnesium, full form of the magnesium and the oxygen. Okay. So there is another, it means a balanced equation. Here, what is the use of this balancing the equations? So once we recall that 9 chapters, it means states of matter. So in that we discussed about the law of conservation. Law of conservation. What is the law of conservation? Here, according to law of conservation, here energy neither be created nor be destroyed, but it can be transferred from one form to another form. Is it? So like that, here also that atoms which are present in the left hand side or in the reactants, and also the atoms present in the right hand side will not be destroyed and will not be reproduced, but it can be changes from one form to another form. So that is the law of conservation. Here also we applied that. Here the chemical balancing the equation, which is totally depends on the law of conservation. It means neither be destroyed or not be created, but it changes from one form to another form. That is the balancing equation. See, let us discuss how to balance the equation. See, for this we discuss first we take in zinc reacts with the sulfuric acid H2SO4, which gives rise to the zinc sulfate ZnSO4 and liberates the hydrogen gas, which liberates the hydrogen gas. Here in this equation, that zinc reacts with that sulfuric acid. Sulfuric acid, it is nothing but hydrogen sulfate, okay, which having a hydrogen, sulfur and also oxygen, which gives rise to the zinc sulfate and releases the hydrogen gas. We liberating of the hydrogen gas, it is represented by the upward arrow mark. Okay, so here when the atoms of the LHS means reactant side. Here the zinc, and which are the first we should make a table. Zinc, hydrogen, sulfur and oxygen. So these are the elements which is present in the chemical equation. And in the LHS, how many atoms are present? Zinc is 1. Is it? Zinc is 1 and hydrogen is 2. Hydrogen is 2 and sulfur, it doesn't have any, so sulfur is 1 and oxygen, it has a 4. Oxygen, it has a 4. It is in the LHS side. And if you observe in the RHS side, so zinc, here also it has a 1. And hydrogen, here also it has a 2. And sulfur, both side it has a 1. And oxygen, O4 is there, and here also O4 is there. It means it doesn't have any changes between the left hand side and also right hand side. Hence, it is a balanced equation. It is a balanced equation. There is no need now to changes the atoms. Okay. So, it is not need to balance. But If you take the another one example, for example, Fe, iron, reacts with the water, which gives rise to the Fe3O4 plus H2. Fe3O4 plus H2. It means hydrogen gas is liberated. So, in this equation, if you observe that the atoms present in the left hand side and the right hand side, it is totally imbalanced. Is it? First, we should write that the elements present in the both side, Fe, hydrogen, and also oxygen is there. And the atoms present in the left hand side is Fe1, hydrogen is 2, and oxygen is 1. Is it? There is no 1. Okay. So in the right hand side, Fe is 3, hydrogen is 2, and oxygen is 4. Oxygen is 4. So if you observe this table, you may find the differences. Iron, Fe means iron. The reactant side it has an 3, but in the reactant side it has an 1, and product side it has an 3. Okay, and if you observe the hydrogen, both reactant side and product side both it has an 2, but in the oxygen here the reactant side is 1 and product side it has an 4. Then how to balance that equation? First we should mark that or make a box for the having atoms, those we having atoms. So these atoms we should not be changes during the balancing equations. By multiplying we can be make the balance of the equation. It is just like a trial and error method. There is no need a formula, and there is no formula for the balancing equation. It is just trial and error method. So to balance the equation, first we should take that the highest number which having a differences. The highest number we should take. Here, which one is the highest number? Oxygen. Is it? Oxygen is the highest number. First we should balance that oxygen. How to balance that? See, you know that here in the right hand side it has a 4, but in the left hand side or in the reactant side it has it has only 1. So by multiplying 1 into 4 we can get the 4. Is it? So it means 1 4 is 4. We can balance the oxygen. And now that oxygen is balanced in the both side, but there is a increase in the there is caused the changes in the hydrogen, because that hydrogen it has a 2 by into 4. 4 into 2 means 8. So here we have the 2. By multiplying the 2 into 4, 4 2s are 8. Here also 4 2s are 8. 4 2s are 8. We can get that 8 hydrogen atoms. Is it? So like that we can change the atoms. So now that hydrogen and oxygen both are balanced. But here we have that iron. Fe means iron. Here it has 1 atom and here it has 3 atoms. So by multiplying the 1 into 3 we get that 3. So that here also we get the 3. So like that we obtain that balanced equation by multiplying the numbers. So it means 3Fe plus 4H2O gives rise to Fe3O4 plus 4H2. So it is a balanced equation. So after that writing the hydrogen, we can represent it by the upward arrow mark. If any precipitation occurs in the equation, means we can be represented by the downward arrow mark. Can also represented by the downward arrow mark. Why? Because means the hydrogen it liberates. So while we liberate that hydrogen, oxygen, chlorine, such gases, so we represented by the upward arrow mark. So that should be very important. Okay. So this is about the balancing of the equations. If you have any doubts, means we can you can WhatsApp to the group, and also I will send some unbalanced equations to the group. You have to do work on the equations. Okay. So next topic is the types of the chemical equations. Here, the types of the chemical equations, mainly it has four types. One is chemical combination. Second one, chemical decomposition. Third one, chemical displacement. And fourth one, chemical double displacement. So these are the major types of the chemical equation. In that, the first one, chemical combination. See, the chemical combination means the two reactants combine together and form a new product. Combine together form a new product is called as a chemical combination. For example, you know that carbon is heated in the presence of the oxygen, which gives rise to the carbon dioxide, which is in a gaseous form. Hence we represented by the upward arrow mark. Here that carbon, which is in a solid state, you know that coal or coke, these are the some example for the carbon. This carbon is heated in the presence of the oxygen which is in a gaseous form. So heat can be represented by the triangle, a small triangle arrow mark. So it represents the small triangle arrow mark. It represents the heating of the mixtures. So which gives rise to the carbon dioxide. So that it is also gaseous form. It is also gaseous form. Hence, it represented by the upward arrow mark. So like that, we can form that the carbon combines with that oxygen, which gives rise to the carbon dioxide, which is a type chemical. It is an example for that chemical combination. Okay. So like that, we have also some other examples. For example, silicon is heated in the presence of the oxygen, which gives rise to the silicon dioxide. Here also we can find that the silicon is solid in state and oxygen is gaseous in state, and that silicon dioxide is also evolves the gas. Here also will represent the heat. Okay. So like that we can give many examples for the chemical combination. That chemical combination, it is nothing but the two reactants are combined together form a new product we called as a chemical combination. Okay. So this is about the chemical combination. And next, coming to the chemical decomposition. Here the chemical decomposition, that name itself says decomposition means splitting up, which decomposes or decays. Okay. See, a reactant or heavy reactant decomposes or splits into two or more products. Two or more products are called chemical decomposition. Chemical decomposition. For example, you know that CaCO3, calcium carbonate, is when we heat it, it decomposes into a CaO plus CO2. CaO plus CO2, calcium oxide, and releases the carbon dioxide. It means a heavy reactant which splits up into CaO, calcium oxide, and releases the carbon dioxide. So like that we can see that some other examples are there. You have to list out them, and that is the homework for the types of chemical equation. Okay, so reactants, once again I will recall that chemical decomposition. The chemical decomposition means a heavy reactant decomposes or splits into two or more products are called as a chemical decomposition. So example, calcium carbonate, CaCO3 heated, which splits up into CaO, calcium oxide, and releases the carbon dioxide, CO2. So it is an example for the chemical decomposition. See, in that chemical decomposition, we also have some other types. Maybe thermal decomposition, electrolytic decomposition, photolytic decomposition. So these are the mainly three types of decomposition. One is thermal decomposition. Second one electrolytic decomposition, and third one is photolytic decomposition. It means you know that thermal decomposition means by heating the substances which splits up into two or more medium nuclei. So you know that calcium carbonate. So again I put it CaCO3. So that calcium carbonate splits up into calcium oxide and liberates that carbon dioxide is an example for the thermal decomposition. By heating the substances or by heating the heavy substances which splits into two or more medium nuclei, they are called as a thermal decomposition. And electrolytic decomposition, it means by passing the electricity. Yes, you know that the electrolytic method to purification the metals, we use that electrolytes. Okay, so here water can be decomposed. It means hydrogen H2O, it can be decomposed into hydrogen and oxygen molecules. It can be decomposes the water into hydrogen and oxygen by using the electrolytic method. So this type of decomposition are called as an electrolytic decomposition. Here it doesn't have balancing. So let us try to balance the equation. You know that hydrogen it has an 2 and oxygen, sorry, here it has an 2. So hydrogen is balanced, but oxygen it has an 1. Here it has a 2. To balance that, by multiplying the 1 into 2, we can get the 2. So it becomes 2 oxygen, but hydrogen becomes 2 2s are 4. So by multiplying by 2 into 2, we can get the 4. So like that, we can balance the equation. Already from 8th standard, we are try to balancing the equations. Is it? So that it is not a big problem to balance the equations. Most of the students are ability to balance the equation. So like that, we can give an example for electrolytic decomposition with the water. Okay, and coming to that, the photolytic decomposition. It means photo means light. Photo means what? Light. Using that light, also we can decompose the substances. For example,